Good afternoon, everyone. Thank you for joining me today. I'm happy to be here to talk about screenshot testing. You might have noticed that this is the second session at this year's DroidKaigi focused on screenshot testing. I think this highlights just how popular the topic is and how many people are paying attention to it. In this talk, we'll explore why screenshot testing is an essential practice for real-world Android projects, as well as some challenges we face when pushing the boundaries. Let's dive right in. Firstly, let me introduce myself simply. I'm currently a senior Android engineer at Unix. You can find me on X or on GitHub by the accounts. I'm a big fan of anime, and I love spending my time with snowboarding, playing tennis, and hiking. Then let's get started with the main topic of today's presentation. Let's start with a simple question. How confident are you with your changed UI? Actually, in Unix, we were not that confident. Also, we have unit tests, instrumentation tests, and other tests. We are still rely heavily on QA team to manually test UI changes, which can be time-consuming, repetitive, and prone to human errors, of course. Let's address more challenges we face when dealing with UI changes. I think it's not just in Unix. All Android developers face the challenge of ensuring UI changes working across a wide variety of screen types, such as phone sizes, tablet sizes, and even foldable sizes. Additionally, we may also encounter non-standard screens, like in car devices. The second challenge we often face involves nested components, like the purchased badge shown in this slide. When we change just one line of code for the purchased badge, all the places using it, we have to make sure if it keeps the UI consistent. The third challenge, and certainly not the last, is maintaining UI consistency during your major refactoring efforts. For instance, currently we are migrating from multi-activities to the single-activity architecture. You can learn more about this from the Yudin Hondo's speech. Throughout the single-activity migration, our goal is to ensure that navigation behavior remains consistent. Also, as a popular trend, you might already planning the migration to Material Design 3. I believe this will require even more attention to UI consistency. Given all these challenges, there is a clear need for a more reliable and efficient way to test our UI. So why not bring screenshot testing into the mix? Let's explore how it works and why it can be a game changer for Android development. Here is how it works. It's very simple. It just takes screenshot and compare. Firstly, it takes screenshot of the UI during the tests. Then it compares this screenshot with reference images, which represent the before UI state. Finally, it flags any visual differences. Typically, the results of screenshot testing are presented in a three-way diff report. This report includes three images: the reference image, the actual image, and a diff image that highlights the difference between them. This format makes it super easy to understand the UI changes at a glance. Let's take another look at the responsibilities of screenshot testing and other testings in our development process. From making changes to the code to deploying our app, we have several layers of testing to ensure code quality. As you can see on this timeline, it all starts with unit testing, which focuses on individual logic functions. Next, we have instrumentation testing, assess how components interact with the app. We may also perform additional UI testing to ensure that the UI not only displays correctly, but also functions as intended. Finally, we conduct performance testing and E2E tests. These are key for validating the app's overall functionality and performance before deployment. And here is where screenshot testing comes in. To effectively confirm UI consistency, whether it's for individual small components or a whole complex screen, it's important to note that it doesn't evaluate whether the UI logic or business logic is correct. Instead, it just focuses on comparing the before and after images to ensure that the visual appearance remains consistent. Here are the key benefits of screenshot testing into your development process, which includes visual regression detection. This ensures that changes in the code don't unintentionally alter the appearance of the app. And the automation of UI verification, of course, which instead of manually checking the UI after each change, it automates this process, saving time and reducing the potential for human error. The third is consistency across devices. As I have said, we have to face to deal with a wide variety of devices. It ensures the UI looks consistent across the different types of devices. The fourth is enhanced confidence in refactoring to make sure any big refactoring changes haven't introduced any visual bugs. Now that we have covered the usage and key benefits of screenshots, let's look at what we're discussing today. First, we're diving into the implementation of screenshot testing. Let's walk through two tools, roborazzi and compose preview screenshot testing. And next, I'll share some experience of my own project, highlighting the whole architecture we are using and the current status. Finally, we'll discuss some additional challenges that arise when testing adaptive layout and animations, and how screenshot testing can help address these complexities. Firstly, to start bringing screenshot testing, you might wonder how to implement it. Which library should you use? Here is a list of some popular libraries you can use to implement it. Actually, sorry I haven't had the chance to work with all of these libraries. Today, I'd like to focus on how to implement two specific tools, which are also seems the most popular one, roborazzi and Google's with a very long time, compose preview screenshot testing library. These are the tools I worked directly, and I believe they offer powerful solutions for integrating screenshot testing into your Android projects. I'll start with roborazzi, which is highly shared in lots of speeches, blogs, even in Google's official documentation. It's an open source Android project created by Takahiro-san. And it has been implemented in projects like our favorite now in Android and in the Droid conference apps. As its name, it works seamlessly with RoboElectric, which is a popular framework for running Android tests on the JVM. This integration allows you to capture screenshots during your tests without needing any emulator. And it uses RoboElectric native graphics to render previews, ensure a more accurate screenshot of your components. To understand how it works, let's look at a very basic code. Here is a very simple code to run the screenshot testing for a single component. The first line about configure lines tells the test to run in Android JUnit 4 test runner and set with native graphic mode, which allowing for accurate rendering of UI elements, and run in specified device pixel 7. Also, you can have other configurations to make your own test environment. Then simply set up a composed test rule, as I want to provide the test running compose UI tests. In the test function, which is important but also very simple, call set content to set the composable component. Here I stated setting screen success composables, and call roborazzi's function capture robo image to take the screenshot. Here I captured the root view of the compose. roborazzi has several capture functions to support different requirements. There has two ways to trigger the testing process. First is record process. It records current screenshots as reference images. The second is compare. Compare is also record current screenshot as a new image and compare with the reference ones. And then you can get the test result with the three-way diff report to highlight the changes before and after. After one single test, you might want to run testing for all your UI composables. And of course, you can write the test all by your hands. But we are engineers, we want everything to be automated, right? Roborazzi actually do have solutions to automate the testings for all your composables. No need to manually create each test by hand. This way, we ensure coverage while saving lots of time for creating and maintaining and reduce the potential for mistakes. Here is one of the popular solutions. It can automatically perform screenshot testing for all your compose previews. However, please keep in mind that if your component doesn't have a preview, it won't be included in the tests. This approach needs a tool like Showcase to gather all the preview composables in your project. Once you have the list, roborazzi can then take screenshots for each of them, ensure that your UI components are visually validated without manual intervention. This is a simple code example to demonstrate how to set up automated testing with roborazzi. However, it's important to note that due to a limitation of Showcase, you can only retrieve the list of public and internal preview components. Private ones won't be included. The first configure lines are same as a single testing. You can configure the specific environments you want the test runs on. Please note we are using the parameterized roboelectric test runner to run tests with parameters, which allows us to pass multiple test cases into a single test method. In this case, we pass all preview composables into a single roborazzi test method. At the bottom of the code block, the companion object section contains a static method to fetch all components from Showcase. The components function retrieves the metadata for all composable annotated with preview and returns them as an error. For each roborazzi test, get a single preview composable from the component list. By getting a single preview component, same as single testing, calling roborazzi's function capture robo image to take the screenshot. Here we can see the testing reports, also in a three-way diff report from running automatic screenshot tests with roborazzi in a very clear way. To use roborazzi, we need to configure and write some test code, right? However, you might still be looking for something simpler, perhaps a way to get started without needing to dive into testing framework. Actually, with compose preview screenshot testing, I will call it CPST in my slides, the automation process can be even more streamlined. In the next few slides, I'll explain how CPST can simplify your testing workflow and help maintaining the visual consistency. I'll introduce CPST first. It's still an experimental tool developed by Google. It was introduced at this year's Google I/O and still in its early stages. As its name, the Compose Preview, blah, blah, it works seamlessly with Jetpack Compose, allowing you to automatically test all your composable previews. The best part is that it's designed to be as easy to use as creating those previews. In other words, if you are already familiar with Compose previews, integrating CPST nearly costs nothing. This line works as easy as composable previews quoted from Google's official documentation, and I have to say Google has done a really good job of delivering on that promise. Let's recap about if we want to write a test code. We often have to jungle the various testing tools and frameworks like JUnit, Espresso, Roboelectric, Mox, and other things. That's a lot to manage and a lot to learn. But what if we could simplify this? This is where the promise of automation and smarter tools like CPST comes in, eliminating the need to manually writing all this test code for screenshot testing. I'll explain how to set up it. Firstly, ensure your environment. Just check your version of the DroidKaigi and Android Studio. Second, add the necessary dependencies in your Gradle files. And lastly, add the preview you want to test directly in the screenshot test source set, not in the main source set. I suspect this step is required because CPST is still in its experimental stage, so Google wants to keep it separate from the main source set from some production environment. And it's all be done. You can enjoy running screenshot testing without any test code. Here is an example of the report generated by CPST from the sample app, quite same as roborazzi's report, clearly highlighting the difference before and after. Additionally, as it's still under experimental stage, I list up the main ongoing discussion about CPST, including some feature requests, especially the first feature request. People don't want the preview to keep in another source set. And other requests like more customizations and for more complex composables or integration with other framework. Also, here is a hot discussion that people are concerned about the future of this CPST versus current solutions like paparazzi and roborazzi. They're concerned how they work together or how to migrate it. And let's recap of this part. I wrote a comparison about roborazzi and CPST. They share common features like both support Jetpack Compose. They can capture and validate UI difference even down to 1 DP change. And for roborazzi, its strength is it's flexible and supports both compose and traditional views. It also offers customization options. However, the limitation is that it requires a setup, requires the knowledge of test frameworks. For CPST, the strength is it's fast, it's integrated directly with the Jetpack Compose, and making it a very streamlined solution for testing. However, the limitation is that it's still experimental with some bugs. Overall, choosing between these tools depending on your project's specific needs, the complexity of your UI components, and how comfortable you are with the setup and integration process. After discussing together about the basic knowledge or the implementation of the two main screenshot testing tools, you might be curious about a real-world project, how to integrate the tools, how to maintenance, and what issues might face. Let me share the experience of our project in Unix. In our large-scale project, we choose the roborazzi and showcase combination to achieve automated screenshot testing. And we combined them with a multi-module configuration, and we automated it with GitHub Actions. This setup allowed us to efficiently maintain visual consistency across the entire project while integrating seamlessly into our CI/CD pipeline. Here is a very simplified module dependency graph, like the app UI domain data module each large project might have. And that's how we integrate screenshot testing into the existing multi-module project. In the middle of this graph, we have the screenshot Gradle plugin. This is the key for implementing the showcase dependency and other configurations required by screenshot testing. Then we added the screenshot test module with the common test code to do the automatic things. And for UI modules, it has many sub-UI modules. Any sub-UI modules you want to include in the screenshot testing process, just simply add the Gradle plugin. Because the showcase inside the plugin once has been implemented, any preview composables will automatically be included in the testing method. And then let me share the how-to configure for CI. Here is the process. When any new pull request, new merge into main branch triggers two workflows. First, the record workflows to record the current screenshots. And the second, just a compare workflows to compare the new images with reference ones. If the second workflow finishes, it triggers the third workflow to comment in the PR. You can get the workflow configuration files in the links I passed in this slide. Here is the simple CI result of the sample app. We can see the record and compare workflows are triggered in a PR, and at last, the comment results can directly shown in the PR. We clearly need to know a list of all the UI changes made in this PR. And let me give you a quick overview of how our screenshot testing setup has been running. We started over 4 months, and Okay. We currently manage around 500 reference images. These images, not all of our compose views, of course, but covers the main UI components and screens we want to test. A CI job runs around 10 minutes on busy days. Actually, it's because of the limitation of CI environment. In local environment, it will cost around 1 minute or 2 minutes. We also had a discussion, GitHub discussion about the feelings and feedbacks when using the screenshot testing. We had some good feedbacks and also had some issues. To summarize them up, the good thing is that easy to see UI changes, of course, and give confidence to the PR owners. Also can help the reviewers to see the UI changes at the first glance. And it's really a good preparation for big refactoring. The encountered issues, actually we had a lot, but we fixed all of them. Please check my speech in Shibuya APK. And so far, we have explored the implementation of screenshot testing and shared the overall experience from my project. I guess we have got a common level understanding of screenshot testing, but I can imagine some of you might be wondering, what about a more advanced use case? What happens when things got more complex? Well, since we have some time, let's dive into that. I'd like to share some of the specific challenges we might face as we push the boundaries of screenshot testing. Firstly, as I shared at the very start, we always have to deal with different screen types in Android development, like non-list screen, foldable screen, or tablet, or any other screen types. Here is some example of our previews for different screen sizes in our project. So I want to bring in the discussion about how to deal with adaptive layout. Also, another big challenge, animations, which are everywhere in modern apps. Let's dive into these real-world challenges. I believe solving these issues is essential for improving the quality and reliability of Android screenshot testing. Firstly, let's look at the adaptive layout. Tests for adaptive layout need to consider about the situations below, like multiple device types, orientations, themes, and fonts. Here also, if you are interested, we have another speech about how to customize adaptive layout. And yeah, let's look at CPST first, as it's super compatible with Jetpack Compose. Actually, you just need to add the annotation you want in the preview. The screenshot testing will automatically run the required configurations. The result captured image looks like this. From the name, you can see the different font scale, screen sizes, dark theme, light theme can be processed. Also here has some example screenshots being captured with the different configurations. But things are not always that easy. Some of you might have noticed that I have commented out a few lines of the annotations. Why? Well, unfortunately, such as the preview screen sizes, it triggers an issue that the results are almost the same at the same screen size. Another issue I encountered during this process was trying to configure specified device types. As you can see here, I set the annotation with device tablet or Pixel 7, Pixel 4, even though the preview with these allocations display correctly, but the screenshot testing with the same annotations triggers built-in error, which says it can't find the specific device resources. So for CPST, it's still not stable for all the preview annotations. On the other hand, let's look at roborazzi. If you want to configure roborazzi by different test environments, you can add the customize line as this slide shows. Through the example, by calling the runtime environment set quantifiers function, you can configure lots of settings like screen sizes, density, themes as you like. And as roborazzi is quite flexible, there has more solutions to set your own test environment as you want. I just learned it from yesterday's speech by Toyama-san. Here is the result after setting different test environment for roborazzi. Also, I passed some example screenshots captured by the different configurations like screen sizes, font scales. To summarize our discussion on adaptive layout, firstly, for CPST, the good point is that it natively supports annotations, makes the test being very simple. However, as we have seen, the pain point remains because it's still in experimental stage with unresolved bugs. Moving to roborazzi, it shines in its configurability. One of the major strengths of roborazzi is that it can be highly configurable for different testing environments. However, the downside is that it does require a lot more manual setups, and there are also some inherent limitations in terms of what it can handle automatically. So then, as an important part of animations for modern Android developers, let's discuss how to do screenshot testing for animations. Firstly, let's recap the different types of animations that we generally encounter in our development. The first is Android built-in animations. These include default animation like process, bars, and shared element transitions. And the second, we have venue-based animations. These are more customizable, allowing you to animate specific properties like translating, rotating, or changing the alpha of an element. And we have animated vector images. A popular example here would be Naughty animation, which use JSON-based vector animations and provide a lot of flexibility when it comes to add complex animations in apps. This is a list of our animation types. The first challenge when dealing with animations is capturing a static state of an animation, particularly for venue-based animation and built-in animations. To achieve this, we can manually control the animation states and capture screenshots at a specific points in time. For roborazzi, you can set the designed animation state directly in the test code or in preview functions as a parameter. For CPST, you can only set it in the preview as it doesn't have a test code. This is a simple code to set the progress state of a loading progress bar in the roborazzi test code. By setting different states, we can get different screenshot results. You can decide your own several key states to be captured for the animations you want to test. The second challenge is capturing a Lottie animation. Since Lottie animations are a bit more complex than typical venue-based animations, we need a specific approach. Firstly, in the Lottie compose code, we set the iteration for the animation to 1, so it only plays through once, making it easier to capture. In the test code, we wait until the composition is idle and then take the screenshot. Currently, the approach only works for roborazzi because compose screenshot testing still has some issues. While this solution isn't perfect actually, it allows us to handle basic Lottie animations in a test environment. Here is a sample code to set Lottie compose code sets an iteration to 1 only for our testing process. And the example code to set waiting the composition to idle and call capture robo image function to take the screenshot. Now let's take a look at the results. On the left, we have the preview of a Lottie animation where we can see the dynamic nature of the animation. On the right, the screenshot results, which successfully captures the final state of the animation. While the animation itself is dynamic, the screenshot reflects the end of the animation cycle, showing how we can capture keyframes even in complex animations like Lottie. The third challenge we can think about depending on a special feature of roborazzi. Regardless of the animation type, we can capture a sequence of screenshots and convert them into a GIF image, providing a visual representation of the entire animation sequence. And yeah, it's only a feature of roborazzi, and it can just be stored, can't be compared at present. The sample code looks like this. Sets the capture type as GIF in the test rule, and in the test function, just set the content trigger some user events. This slide shows an example of a venue-based animation results. While the GIF may not appear perfectly smooth, it effectively tracks only the changed states of the screen. This approach is sufficient for testing animations, and it also helps reducing storage spaces. I have also passed the result of a Lottie animation screenshots. It seems that for more complex Lottie animation, the GIF primarily captures the start and end state of the animation rather than the entire sequence. Now let's summarize what we have discussed about testing animations. Actually, the current solutions are most sufficient for testing Android animations, but there's still rooms for improvement. Like we want a simpler approach, we want the GIF smoother, and we want more customization. After discussing the challenge about testing for adaptive layout and animations, here comes to a more interesting part and last part, deal with a complex situation by combining them. Now I'd like to take a practical example from Material 3's experimental API, the List Detail Pane Scaffold. This API is designed to automatically decide whether to display 2 panes or just 1 pane, depending on the screen size. For instance, on a tablet-sized screen, it shows a list and a detail view side by side, but on a phone-sized screen, it switches to a single pane layout with a list first, and then detail view after clicking an item. Now you might already be thinking about how to test this with screenshots. We need to configure the environments for both screen size and simulate user interactions like clicking on an item. To recap the solutions, roborazzi can do the customization settings. And the CPST can't work because of mentioned issues. Here is the simple code snippet to show the environment configuration and user clicks performing and then calling the capture screenshot function. And then we can get the perfect result to capture the screenshot for List Detail Pane Scaffold composables. Yeah, thank you for sticking me with over nearly 40 minutes. To wrap things up, let's do a quick recap about what we have covered today. Firstly, we talked about the implementation of screenshot testing. We explored the 2 main tools for it, like roborazzi and Google's Compose Preview screenshot testing, and I shared the experience of our projects about how we integrate these tools and our feedbacks, feelings about it. Finally, we discussed some of the ongoing challenges we are working on, particularly around testing adaptive layout and animations. This covers the foundation of implementing effective screenshot testing for Android apps and how these tools can significantly contribute to improve UI testing workflows. And at last, all of today's examples are involved in my sample apps. If you are interested, please check it. Thank you very much. ご清聴ありがとうございました。